Hey guys, welcome to the video where we're gonna talk about the TCP/IP model. The TCP/IP model is not extremely important for network engineers, but the whole internet is built on it. So for example, every device which is IP based has the TCP/IP stack installed on it. The TCP/IP was created by the Department of Defense in US, which is this one. And the updated version, that is not officially, but Cisco presented it in this way to make you understand it. So this one is presented by Cisco. The TCP/IP simplified the 7 layers of the OSI model into 4 layers, which are application, transport, internet, and link. The last one can also be found under the naming of network access layer. Because everything from layer 7 to layer 5 happens in the application, in the TCP/IP model, they got converted to application layer only. The transport layer remained the same. The network layer, it's also the same, but only the naming got changed. And the first 2 layers from the OSI model, data link and physical, for some reason that I cannot explain, it changed to link layer or network access layer in the TCP/IP. Or one of the reasons that might be is because of the fact that the operations at these layers are related to hardware. But in the updated version, which was done by Cisco, they got split again. In the last video, we talked about the encapsulation and decapsulation concepts, which were happening in the OSI model. Right now, we were going to talk about the encapsulation and decapsulation concepts for TCP/IP. The process is the same, but is much more simple. In OSI model, we had 7 steps of encapsulation or decapsulation, and in TCP/IP model we have only 5. The first 4 steps relate to the encapsulation performed by the 4 TCP/IP layers, and the last step is the actual physical transmission of the data by the host which sends the communication. These steps can be summarized in this way, that we've done it right here. The computer creates and encapsulates the application data with any required application layer headers. For example, the HTTP OK messages can be returned in an HTTP header followed by the part of the contents of a web page, for example, google.com. At a second step, the data which is provided by the application layer to the transport layer is encapsulated inside the transport layer header, this one. Transport header. A TCP or UDP header is typically used. In our case, because we gave the example of HTTP OK message, we will gonna have TCP port 80. And at this layer, we have the TCP/IP message of a segment. And the data is passed over to network layer, where the data is encapsulated by a network layer, which is IP header. In the IP header, we have the IP address that uniquely identifies each computer. The TCP IP message at the network layer is called a packet. Moving further to the data link layer, the data received from the network layer is encapsulated again by a header and a data link trailer. The message type at this layer is called a frame. The data which is passed from the data link to the physical layer gets encoded into a signal that is passed over the medium of transmission. And these ones are bits, ones and zeros. As we said, these TCP IP messages can be used to identify the proper layer in the TCP IP model. So for example, if we are talking about segment, we are talking for sure about TCP or UDP headers, like for example TCP port 80. In the packet, which is at the network layer, we are talking about IPs, like let's say 192.168.1.100. At the data link layer, we have the frames, which are the MAC addresses of your PCs. That can be something like AE colon 32 colon 1A colon 20. Thanks for watching. Don't forget to subscribe, hit the like button. You can also follow me on Twitter. The link will be in the description down below. And talk to you guys in the next one.